ever-changing ocean, and the pleasures of the nighttime, the forms of all creation, a wonderland of vision. The eye is protected by a deep bony socket. It is marvelously equipped with muscles and a delicate crystalline lens. Truly, the eye is a ball of wonders, nature's masterpiece. The iris controls the amount of light admitted. The cornea is a protective coating. The lens automatically changes shape for near and far seeing. The retina is like a sensitive film on which all light must focus. The optic nerve conveys impulses to the brain, which interprets what we see. The purpose of the lens is to bring rays of light to a point or focus, and the shape of the lens is all important. With no lens to interrupt their journey, rays of light travel in a straight line. If we break their journey with a lens that bulges outwards, we bring the rays to a focus. A lens curved inwards, however, will spread them apart. And so, if our eyes had no lenses, the rays would not come to a focus on the retina. Again, the all-important lens focuses rays on the retina so that we record real images. A common error of vision is nearsightedness. The eyeball in a nearsighted eye is too long. Rays focus in front of the retina, making everything look blurred. A correcting glass lens in front of our own lens will make things look clear again. Another seeing error is farsightedness. The eyeball in a farsighted eye is too short. Rays focus behind the retina. Again, everything looks blurred. Another kind of lens in front of our own lens will bring things back into focus. A thorough examination every year reveals the true condition of our eyesight, as well as important aspects of our health. To the professional examiner, this network of veins and blood vessels at the back of the eye is full of meaning. With the aid of ingenious scientific instruments, our examiner puts our vision through a multitude of tests. And unseen, yet forever in the background, are the men of vision whose genius inspires every detail. Willard Snell, whose laws of refraction enable us to measure lenses with great accuracy. Sir Isaac Newton's experiments with light helped lay the foundation of modern optical science. Thomas Young, who taught us much about distorted vision, or astigmatism as it is called. Von Helmholtz, the first man to look into the living eye, and many, many more. Our modern eyesight examiner carries on this great tradition of visual science. Only years of study, experience, and judgment, aided by precise scientific instruments, enable him to uncover and correct the shortcomings of the eye. These might be blurred vision, double vision, tunnel vision, distorted vision, and countless other faulty seeing patterns. Projected on a screen, letters, symbols, figures, and colors will help our examiner decide on the best lens powers and curves that will bring our vision to its best possible condition. There will also be many intricate reading tests at normal and varying distances. For only by carefully studying all his findings and balancing one against the other can our examiner determine the precise amount of correction each of our eyes will need. Our thanks to all the professional men and women of vision everywhere, to whom we are indebted for the precision and trustworthiness of a modern eye and eyesight examination. Our thanks also to the technician who interprets with the utmost accuracy the findings of our examiner. His job is to take facial measurements to determine the proper size of our lenses. He must see that the lenses are properly centered and angled. He takes into consideration the exact powers and curves that have been specified to guide us in the choice of frames that will hold our lenses at the one carefully calculated distance from our eyes. For any glasses that are not fitted properly can easily undo much of the examiner's conscientious work. Of great importance also is the selection of frames with bridges and temple pieces that really fit our facial characteristics. Careful fitting is essential if we are to get the greatest benefit from our glasses and enhance our looks and personality. Eyeglasses are such simple-looking things, two lenses in a frame. Yet how much science and craftsmanship goes into their making? What blending of fine skills? What surmounting of endless problems? And a constant searching for more perfect methods and standards of achievement. Consider glass making. There are no greater standards of perfection than those to which ophthalmic glass, the glass of lenses, is made. The pot to hold our glass is made from a carefully balanced clay formula. It must be free from every trace of impurity. Scientific blending is the secret of the glass mix. Silica, barium, lime, lead, special and rare ingredients from the ends of the earth. In the great heat of this glass furnace, a miracle will take place. The dull, opaque stuff of the earth will be transformed into the crystal wonder that makes man master of his sight. Stirring, a long, patient job. Every bubble of air must be squeezed out. The glass texture must be uniform. This is a critical operation. The long cooking, sometimes taking days, is finished. Impurities are skimmed from the surface. These pots can hold up to 600 pounds of glass. Yet so high are the standards of quality for ophthalmic glass that only 40 pounds of lenses will successfully pass all their tests. Glass must be handled with care at every stage. It must not cool too quickly or it might crack. In the annealing ovens where our glass goes next, it will be gradually cooled for 12 hours. The varieties of ophthalmic glass are endless, and it takes 363 lens production skills to make our glass into spectacle lenses. When our glass leaves the cooling ovens, it is carefully inspected. The slightest imperfection, waves, stripe, bubbles, cloudiness, and it goes on the scrap heap. This man might handle 2 tons of glass in the course of a day's inspection. All phases of glass finishing call for great accuracy, skill, and judgment. This is scoring the carefully measured glass into squares, or blanks, as they will now be called. The amount of glass in each blank is the gauge to the amount and kind of curve that can be put on it later. And so, weighing is important. It is done by hand, and also on ingenious automatic diamond tip scales. Up to now, our blanks have been flat squares. Here they are molded into round blanks with curved surfaces to better conform to the shape of our eyes. Many fields of science contribute to the perfection of our glass. Fluoroscopic light reveals flaws invisible to the naked eye. Of course, many kinds of blanks are made for many different seeing purposes. These that are being blocked or set in pitch will become the large section in a bifocal. This is the dance of the polishing spindles. It took years of research to find the right polishing and lubricating compounds. This man is not a watchmaker. This is another of the 45 inspections our glass blank will get before it leaves the factory. Matching the 2 sections of a bifocal calls for trained eyes, patience, and dexterity. And because a single speck of dust between the 2 parts will spoil the finished lens, girls work in dust-proof, air-conditioned rooms. Every inch of each compartment in the room is carefully scrubbed every morning. Benjamin Franklin was the man who first thought of combining 2 lenses in one for near and far seeing. Nowadays, we have trifocals, 3 lenses in one, for near point, midpoint, and far seeing. The little metal pins hold the 2 sections of the blank in proper position during the fusing operation. The electric fusing furnace is specially designed to rigid specifications. It is automatically controlled. Although only 20 feet long, temperature gradations are so critical that our bifocals will take 5 to 8 hours for their journey. Our glass cookies are ready. The heat has caused the center of the small lens blank to become fused to the large blank. The little pins we saw will afterwards be ground off. Our 2 lens blanks have now become 1. Starting with milling, some 20 preliminary operations will be performed on our lens blank. It will receive rough grinding, fine grinding, all degrees of polishing and gauging, sorting and weighing. And of course, constant inspection, inspection, inspection. For there is only one standard for the lenses that correct our vision: perfection. Yes, a lens blank looks deceptively simple, yet each single blank must go through every one of these stages. How much has had to be worked out? Studies of light, the complicated mathematics of seeing, miraculous laboratory and shop techniques, incredibly precise instruments, the analysis of countless glass chemistry formulas, unending research and experimentation, the experienced judgment and skill of thousands of artisans, craftsmen, technicians, the centuries of devotion to visual science. Simple indeed. Yet this piece of glass is the culmination of all man's knowledge and work in the realm of ophthalmic glassmaking. Ophthalmic glass that brings to millions of us a new joy in seeing. And so, having made our lens blanks, let us find out how we make our frames. In metal frames, gold is the important ingredient. Gold is beautiful and flexible. It is the one metal that can be worn close to the skin for long periods of time with perfect comfort. Fine, pure gold is also very expensive. Each of these 24-karat gold bricks is worth about $10,000. But gold is soft. It is strengthened by mixing it with other metals. In our finished frames, this precious gold will surround every exposed metal part. To turn it into the various thicknesses of wire and cable we need, our gold will be rolled, pressed, annealed, and drawn. It will be heated, cooled, bathed in chemicals, receiving the scrupulous attention and know-how of skilled gold workers and metallurgists. Here are some of the 59 parts that go into the gold mounting for our eyeglass lenses: bridges, temples, screws, hinges, and the number of operations necessary from the gold melt to the completely assembled frame, one frame, mind you, is 456. These operations call for skilled handiwork by trained and nimble fingers. To make plastic frames, we have borrowed our material from the chemist and our colors from the rainbow. Plastic frames call for as much dexterity and craftsmanship as metal frames. Special machines and processes give them that brilliant luster that is really built in. They go through many carefully controlled stages. It is this unlimited attention to detail that have made American eyeglasses unrivaled for sheer beauty and sound value. Standards of perfection are maintained with constant checking. The frames are mixed with wooden pegs, soda, and pumice in a very interesting smoothing operation called tumbling. And now, having made our frames and watched our glass become blanks, we come to the very heart of lens work: custom finishing in the prescription laboratory to the rigid specifications of our examiner. This is exacting work. A slip of the hand here and this lens blank would be ruined. After axis marking to keep the lens in proper register, a lap or cutting tool will give it the proper curvature. Laps can be machined to thousands of differing curves and combinations. Plus or minus curves, spherical and cylindrical curves, special curves, prisms. Eyes are as individual almost as fingerprints. These custom operations also call for the use of special grinding and polishing materials, diamonds, garnets, the finest rouge, blends of minerals and substances chosen only after thousands of other blends have been rejected. These are only a few of the key operations. There is blocking, cleaning, shaping, drilling, and many, many more. After every step, there is precise measuring, checking, gauging. Vigilant watch to make absolutely certain our examiner's orders are being carried out to the minutest detail. And here are our finished glasses, mathematically exact to a hair's breadth, with a brilliant, flawless surface, frames and lenses scientifically made and assembled, fitted in front of our eyes in their one true position to work modern miracles for our vision. Glasses, 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 every shape, every size, every color of the rainbow. Scientists, artists, craftsmen in plastics and precious metals, designers, chemists, professional men and women in 100 branches of optical science, all had a hand in bringing glasses to their modern-day perfection. Glasses are indispensable to 7 out of every 10 of us, young and old. All ages require them. Besides giving us flawless vision, they enhance our personality, flatter our features. They are also high fashion for all occasions. The up-to-date person has an eyeglass wardrobe to blend eyewear with clothes for every activity, business, sports, social engagements. Having several pairs is also wise in case of loss or breakage. How often has our day been spoiled without them? Our eyesight changes almost from year to year, and our general health and alertness is so dependent on how well we see. A regular eyesight examination can do so much for us. And if we have that, we can count on modern visual science to keep us abreast of every new development, to guard our eyes, to help us cherish our vision, to bring us the utmost perfection in eye care and eyewear for the most precious of all our senses, vision. And what a world of vision this is. What a world of activity, pleasure, and relaxation our eyes bring us. On the job every day of every year, indoors and out, enriching our lives with color, beauty, and 1,001 entrancing sights. Let us not forget, many have labored throughout the years to help us see well at all times, in every stage of our lives. And this labor is unceasing in the multiform realm of visual science. For there, vision is king. To bring us the glories of nature, the wonders of man, and to safeguard the eyes of the future in the wonderland of vision. Nothing you buy gives you so much, yet costs you so little.